Now we are in the 11.2. We're going to talk about the 12.2, sorry. Something else. Here we are going to talk about vector. Our things in 2 dimensions change to the vector. Now we have a vector. And what's a vector? What's the operation on the vector? We are talking about this one. Component form, usually we have a direct line, indirected line, or segment, whatever you have. Of course, for every line that you have, directed or indirected, the important things, we have an initial point and terminal point. So here's your initial point, the start point, and here's the terminal point, the last one that you are going to there. And of course, we have a component, you can see from here. We sometimes the vector is used as the tangent, as the velocity, you know. We have a tangent vectors that we usually use in the calculus 1 or 2, or here maybe we are going to talk about it again and again. So very important, we have a vector and we are going to use the vector. What do you mean by directed? What do you mean by component form? All this one will be mentioned here. Here's the component, and when we have a directed one, we have two important things. It's called magnitude and direction. Okay, magnitude and direction. Later on as well, we are talking about how to find the value of it. Or some book in the physics one is called what? It's called the length and direction. Length and direction. This is the direction. The length is number equal to some number. For example, you say 3, 5, and the direction is what? Is the positive or negative is going to where? We are talking about vector, maybe the vector in the two dimension or 3 dimensions. So both of them are the same. So 2-dimensional or 3-dimension are the same. We have many form of it. One of them is component form. Component form. When you say component form, means that we have a v1, v2 for any vector. Any vector that we have, we are going to find the component of it. We are going to analyze it to x and y. So component is what? Is like a this one's called angle, I don't know, angle bracket or whatever you have. We have something like that. Then we are going to write v1 and v2. For example, I say v equal to 1 and 2. 1 and 2 is not a point, it's the vector component. So point is like that. Vector is like that, the component. Maybe you have 1, 2, 3. Understood here? Good. Now how we get a component, that's a question. So look at here. What's the difference between vector and point and things? We know we have a P and Q, or P1 and P2. And we know between these one we can draw a direct line, which is called vector, or we can bring this one to make the standard. Look, from here we'll bring it to to the origin. Look at here again, please. So here's the component. We are not in the origin, we are at some point. And we are in the other point. So we change that one to the origin. We bring this one, copy and paste here. Then we will find the vector form or component form. So this is called make the standardization. That's why we change between 2 points. We say if I have 2 points, I can standardize it or can change it to the vector like v. You got it here? How? Later I'm going to tell you how. But the important things, if I have 2 points, I have a vector. Clear? When I have a vector, I'm going to write down like a component. Clear, dear? v1, v2, v3. Do you have any question about these words that I said? No, now practice time. Look at here, look at this example. We say that magnitude or length, as well we have what? We have a vector. Magnitude, I told you, it should be what? It should be number. You should get number. Look at that. This is point form. Look at that. This is component form. Both of them the same. If I have P1 and P2, I can find the magnitude number. If I have v1 equal to v1, v2, v3, again I'll get the same number. It depends on the formula that I have. Zero bold is called zero vector. We have a zero and bold zero. Or some book will write like that. Will give you the clue like that. Say 0 or 0v. 0v means that zero vector. Or some other book written 0. When you saw the bolden one, means that the vector, we are on the zero vector. Zero vector means that we are not starting anything. We are going to, like a rocket, we are waiting for going to somewhere. So we are in the stationary, or we are in the initial point that we have. Good. Now, let me start to practice this word. We have a component. Find the component form and length, where this one is initial and terminal is this one. So we have from P is going to Q. Find V and magnitude of V. So how we do it? We know we are going to write PQ, and I'm going to find V1, V2, V3, because V equal to V1, V2, V3. Okay, what's V1? V1 equal to X2 minus X1. You got it there? How about V2? Y2 minus. How about V3? Z2 minus Z1. You got it there or not? Shall I do it for you? Can you imagine how to find them? So here we are. We need to find V1, V2, V3. And I know one by one. V1 is equal to 1. V2 is equal to what? V3 is equal to what? Clear? Hello? Fine? Good. Now I will get what? From V1 I got minus 2. From V2 I got minus 2 again. From V3 I got 1. So this is my component. And it will be my vector. So briefly, we are going, instead of say x2, briefly I'm going to write V equal to something like that. How about length? Length is distance, is magnitude. You know the rule. Look, if you have a component form, for example, V1, V2. If I say find length, directly you are going to do what? You say length of V equal to V1 squared plus V2 squared. The rule changed to easier one. Why? Because V1 came from what? X2 minus X1. V2 comes from 1. Y2 minus Y1. Instead of writing like that, I have directly, I'm going to use that one. You got it here? Is that clear for you? Good. Forget about this example. Is the physical one. If you like it, it's application, you can read it and do it at home. Understood? You can use that in your real life. Here's the example. Any question? Now, we have operations on the vector. What do you mean by operations? We mean by addition, multiplication, subtraction, these that we have. So, first of all, we have what? We have a simplest addition. How we add? We add first component with the first component, second component with the second, third with the third. How we multiply scalar number? Directly to all of them. Can you tell me, give me some example? Let me give you. We have a V is equal to 1, 2, 5. We have U is equal to 0, minus to 1. Now, tell me about V minus or plus U. Directly I see is equal to 1, 0, 6. You got it? How? Hello? You got it how? Okay. How about if I say U minus U? I'll get what? Clear? How about if I say 2U? Tamam? Clear? So this is all about operation or things with it. What do you mean by addition? By addition means that if I have a vector here, I can find the addition between them. If I have a vector here, I can find the addition between them. So that means the extent of them. Clear, dears? Here's an example. Try to do it at home. What do you mean by that? Can you tell me? Huh? Half of? No. No. And you mean is equal to what? You mean is equal to, for example, is equal to minus 1 over 2, 3 over 2, 1 over 2? No. This absolute value means magnitude. You multiply, then find magnitude. Okay, absolute value means that magnitude here. Clear? When so why we have this absolute value? Why we have it? For what? For fun? No, meaning something, right? So يعني magnitude 1 over 2 multiply you, find the magnitude. So you are going to multiply by 1 over 2, then magnitude. What's the magnitude? Here's square, sorry. This one square plus that one square plus that one square. And then the square root. You got it, dear? Hello? So 1 over 2u is different 1 over 2u. That's it. Any question? Yes. Yes. اینجا دیستانس که ماگنیتیود که دوزینو لینک که دوزینو هشت که تو حاصل نایلی چه همون هم یکشته. Okay. ماگنیتیود قیمت که تی. Clear. Good. Look at the property. See a property that we have. First, you can play with the addition. Why? At one emblem vector u1 plus the second vector, you can say second plus 1. So it's called commutative. Any vector can be associative. Yani 3, if I have a 3, I can play with them, right? I can use the parentheses to here, adding these two, then later add w, or you can plus these one, then later add u. Clear, dears? Okay. Number 2, what do you mean by that? Okay. You don't need to study, just think about it. What do you mean by 0 plus u? It means a 0 vector, right? We say that ball is 0 vector. So any vector with a 0 vector is equal to what? Itself. Am I right? How about any vector with its inverse? 0. Okay, 0, right? And if I'm going to that direction and he's going to that direction with the same magnitude and direction, I'll get what? 0. I'm not going to change to go anywhere. This 0 is called scalar 0, it's not bold. Look, أما is number. أما is number. That one is vector. So if I multiply 0 number to any vector, I'll get what? 0 vector, right? For example, I have 1, 2, 3, and I have a 0. I will get what? 0, 0, 0. Tamam? So that's why I will get 0 vector. Do you agree with me? Good. Number 6. What do we have? 1 multiply any vector, you'll get what? Itself. Itself. Good. ABU, any two numbers. For example, 2 multiply 3 multiply u. We can play with it, right? We can say 6 multiply u. How about number 6, 7, 8? How if I have 2 multiply, do 2 vectors? So we can distribute AU or up to you, or you can add them, then multiply by A, right? The same thing is true for the other one, number 9. Now we have unit vector. I'm gonna name it. Just name. You are going to use them. What do you mean by unit vector? Can you imagine? What was unit circle? Do you remember in calculus 2:1? We recall unit circle. Reduce aqui. Yeah, center is 0, reduce aqui. يعني x square plus y square is equal to 1. Well done. So unit vector means that 1. يعني it means 1. Okay, 1. So what do you mean by unit vector? Any vector, if the length is equal to 1, length, magnitude is equal to 1, absolute value is equal to 1, is called unit vector. Okay, so for example, I have I. I is the standard unit vector on the x-axis, right? You know. Am I right? This is I. We have a j, 0, 0, 1, 0. We have k, 0, 0, 1. So this one is unit vector. Do you think that one is unit vector? Let me check. We have I equal to 1, 0, 0. So length of I equal to what, جماعة? يلا. Length of I equal to what? Length of I is equal to 1 square, 0 square, 0 square. I'll get what? 1. So it's unit vector, right? So means that you are right. This is the standard unit vector. Do you have any question? So we can represent a vector as I and j and k. We can represent the vector as I and j and k. So we, instead of v equal to v1 component form, we can write v equal to what? vi plus v2j plus v3k. You got it here? Understood? We can write like that as well. So ij component or form or the component form. طبعا أوش أتوان مالكم. Am I right? We say that. We say p is equal to what? V equal to what? We say as well v equal to p1, p2 if you remember. And how about p1 and p2? It was what? It was x1, right? Am I right? Plus y2 minus y1. So we can write them like this component. Clear, dears? Hello? How we get v1? Do you remember v1? It was equal to what? Do you remember? How about v2? So now bring it to there. I'll get what? I'll get v equal to x2 minus x1 I y2 minus y1 j and go on. Clear? What did I do? Nothing. Because I told you if I have 2 points, if I have 2 point PQ or P1, P2, I can write V and I have many variety, 3 types of the representing. Maybe by that, maybe by that, maybe by that. V1I. Okay, dear? Do you agree with me with the 3? Did you get it? Good, because later on you are going to use them. How we make any vector to be standard, to be unit? What do you mean by that? For example, if you have a vector, any vector, 1, 2, 3. Let me make it 0 to be easier. How this one is? Do you think this one is unit vector? How do you know? يلا دابا تشيكي كم is equal to what? 1 square 2 square square root of 5 not equal to 1, so it's not a unit vector. Why, Kaka? And we need to check it. Okay, so how we change it? How we change it to the unit vector? So I'm going to make it a u by what? By dividing vector to itself, to its length, to its length. همو vector dividing length كيف كيبقى unit vector? How? هذه شنو مهبو 1 over 2 أما length ثانية جماعة ما قرينها بيزان ها. Isn't the length here كاكا? So I'm going to divide by 1. I have what? V it was 1 2 0. Do you remember? So I'm going to change it to 1 over square root of 5. I say u equal to 1 over square root of 5, 2 over square root of 5, 0 over square root of 5 is equal to 0. Now check u is unit vector or not. Yalla. 1 over 5, 4 over 5, and I will get what? 5 over 5, which is equal to 1. Now, what did I do, Kaka? I bring this vector. Summary. I bring this vector 1, 2, 0, which is not unit. I change it to unit by what? By dividing to its length. I got unit. Clear? Hello? Kata, I can get unit vector from any vector that I want. Am I right? Just by dividing. Clear, dears? Now, here's the question for quiz. Now we start. Find unit vector for this. Come on, nothing. So you need to do what? To make a V1, V2, V3, then find the length, then divide it, right? So how we get from 2 points, how we get vector? I told you V1 equal to 2 minus 1. Okay, so look at here. Do you think that one is easy for you? 2 minus 1, 2 minus 1, 2 minus 1. Feel free. Maybe your friend is like that. Wanna write like that. 2, 2, minus 1. Maybe your friend is written like that. Understood? By the component. Now we have a 3, or 2, 2, 1. How we get the length? Square, 4, 4, plus 1, 9. 9 is equal to 3. So the length of V is equal to 3. How we make it a unit vector? I have a V over V. So 2 over 3 minus 1 over 3. Here's the standard or the unit vector. Did you get it, dear? Which second one? That one? That one? We bring it from V. V equal to 2 minus 1, right? So how we find the length? We see square root of here square, here square, here square. Clear now? Easy? But he used another formula. He used here, for example. Understood, dears? Kaka, you got it? Jamaat? Good. Any question? This one for you is the physics one. You just look at it. Example number 5. Look at what's going on. Any question? Again, that one as well for you. Not important, just look at it. Read it and see what's going on. It's talking about force and magnitude and things like that. Any question, dears? We're going to stop here. Let me finish. That's just only one small thing remains. So you have a midpoint. What's the midpoint, Kaka? Lady, 2 minutes, no more. What's the midpoint? Hello? If I have 1 and 3, where is the midpoint? How do you know it's 2? Because I say midpoint is equal to, for example, x1 plus x2 over 2. 4 over 2. This is for 1 dimension. How about 2 dimensions, 3 dimensions? The same. You got it? That's the same. So here's the point. Please find the mid. You will see it's easy. You have a exercise 1.2 and there's a selected one. Try to do it at home.